radon has a half-life of
Radon.
3.38 days. After 7.6 days, 6 grams remain. What's the mass of the original sample? So when we go from 0 days to 3.8 days, it's going to have once. And then in another 3.8 days, so we're going to add 3.8 plus 3.8, we're going to get 7.6. It's going to have again. So between here, it's going to have once, and between here, it's going to have twice. So it's going to have 2 times. We don't count this as 1, 2, and we do not count this, as 1, 2, and 3. That is not the correct way. So this is wrong. Instead, we count the jumps between how many times it halved.
And I don't love the way she wrote this. I wish she wrote 1 and 1 and then wrote a 2 over here. Y'all with me on that?
And so we know it halved twice. And so we started out with 6, or so we ended with 6 grams. And we know that it halved from what? Well, it halved from 12. And 12 halved from 24. So it halved once here and it halved twice here, or technically it halved once going from 24 to 12, and then twice going from 12 to 6. And so by working backwards, we can figure out that the mass of the original sample was 24 grams.
I wish they would have given you the problem.
And so that's how you do these. You do these by kind of working backwards and sketching it out. There is not a formula that you need to use for these problems. Let's go on to number 2.
I don't like this. Sorry. Let me find something different. Give me a second here. I thought this was Shelly's video, but it's not. Is this Shelly's video? It's not Shelly's video. All right. Shelly's my friend. She's one of my greater friends. I have like 2 friends. Okay. What's this do now? All right, let's watch the beginning of this one. We're not going to watch this whole thing. This has the problem.
All right, guys. Hi, I'm Max. And today we're going to be talking about half-lives and how to solve problems involving half-lives. So a half-life is what we use to describe how fast the decay process happens for a radioactive element, right? So think about a half-life in terms of the original amount that we start with, right? So if we start with 100% of our material, over time, it's going to decay and it's going to disappear. So half-life is how long it takes to get from 100 to 50% of the material, right? So that's the length of our half-life, and that is denoted by T1 half, all right? So now, if we start at 50% and go to 25%, so we divide by half again, it's going to take the same amount of time, and that's what a half-life is. And even if you go further back, divide again to 12.5, it's going to be the same length because it's the same amount of time. All right. So now let's look at a practice problem. Because the purpose of this video is to describe how to solve problems involving half-lives. So that's what these questions are. We're going to have about 3 practice questions, right? So the first part of a problem is to define your variables. So figure out what you know and what you don't know, right? So there's 4 variables for these problems, right? So they're going to be these right here, right? So what's the total decay time? What's the half-life? What's the initial amount? And what is the amount after our decay curve, which is MT, right? So let's look at what these are going to be. So our half-life of cesium-137, it says it's going to be 30.2 years. So let's write that right here, 30.2 years. So it says The initial mass of the sample is 1 kilogram, so that goes right here, right? 1.00 kilograms. So, and then it says, how much will remain after 151 years? So we know the time there, that goes there, 151 years, and we want to know how much will remain, which is MT. So the second step is to find the number of half-lives.
And you don't
So
have to
find the
do,
number of half-lives. And the way we do that is find the variable that we have 2 for. So in that case, it's going to be our time variables. We have both of those values, right? So it's our time valuables. So to find the number of half-lives, you simply take the total time and divide it by the number of half-lives. So for example, for this one, it's 151 years divided by 30.2 years. So what's that going to equal? That's going to equal, let's see, 5 half-lives. So cesium-137 is going to go through 5 half-lives in 151 years. So the second step is to utilize the equation. So the equation looks like this.
is that, like, is everybody good with that? Like the whole, like, okay, so we got 151 years, 30.2, right? That would give us the 5. Are we okay with that? And I know, I'm sorry, I gotta say all this stuff, and I'm sort of like, oh my God, shut up. Okay, cool.
MT equals our initial mass divided by 2, and in the exponent we have the number of half-lives. All right, so now we simply plug in our variables. So for initial mass, we got 1.00 kilograms divided by 2 to the, and we just got 5 half-lives, so the exponent's going to be 5. So this is going to be, and I already calculated this out, it's going to be 0.03125 kilograms, right? So after 151 years, cesium-137 decays from 1 kilogram to 0.03125 kilograms. All right.
Okay, my math people in here. If I don't, yeah, he is. I don't like his handwriting, but whatever. Okay, if I know, is there another way to do this, math people? Like, if I get my, what if I blank out and I got, okay, I can get my 5 half-lives. Math people, tell me, is there any other way to do it than 1,000 divided by 2 to the 5th?
I mean, you could do 100 divided by 2 5 times. That's the other way.
Okay, 100. So if you're like logically like freaking out, you're like, I don't know how to get this. You can just take 1 divided by 2 5 times. Okay, y'all with me on that? Okay, that's for this. That's for this, the person. Like, if you're like, I'm not giving you a formula here because you forget formulas, right? I forget formulas. You're not going to get formulas on this stuff. So think logically. Okay, I like that. Thanks, Addison. That's perfect, right? Okay, so if you're like, okay, crap, I got this 5 years. Okay, so how much is going to be left? Of course, the easy way to do that would be 2 times 10 to the 5th. But like, if you freak, there you go. Logically, do you all see how to get this half-life thing? Okay. Okay, good. All right. Traditionally, we've got a percent change. We've got a, energy question, but you're just finding the answer. The half-life is here. The other one, which I will be 1,000 times shocked if it's not on there, and this is the easiest one of all, is this one. It is dt equals 70 over r. Okay, if this isn't on here, I'll give you all $1. Okay, but don't lie to me. Okay, I'll be shocked. Okay, it's been on every single APES test from now until forever. Okay, this is one you're going to have to memorize the thing for, but hopefully you can remember this. DT stands for doubling time, right? And remember we talked about population. We looked at the doubling time. If the doubling time is low, that means your population is exploding. If your doubling time is high, that means your doubling time is not. So R stands for rate. Now, here's why I'm mentioning this now. This is why if you miss this question on the APES exam, this is why. Okay, and you could do this whole proof in calculus. You prove it in calculus, right? Is this right, calculus people? You can't prove things, or what's that? Yeah, okay, right. So like, I don't know, one time somebody was taking a college class and they're like, hey, we just learned how we got this. Okay, I just accept it as math. Okay, but here you go. Every math teacher from like, I think Ira's class probably teaches in this too, in second grade. When you see a percent, what do they automatically tell you to do? Put it into a decimal, not for this one. Okay, so if we have a growth rate of 10%, it's 70 divided by 10, and it's 7 years. Y'all with me on this? Okay, don't change the percent on doubling time. Okay, it's just 70 divided by that rate, growth rate's 10%, 7 years. Okay, y'all with me on this? Okay, if it was like 20%, it'd be 70 divided by 20, so it'd be 3.5 years. Okay, so that means like their population will double in 3.5 years because their growth rate is so high. Y'all with me on this? That's what you're gonna see on the map. If you're freaked about math, there are tons of videos on there, tons of examples. You can walk through that sort of stuff. I struggle every year. How much do I spend? Like on these things, but like, hopefully this gives you the cheats. I'm more about the cheats, okay? And the knowledge behind everything, okay? Will there be some other math problem that I don't know about? Maybe, but half-life, doubling time, percent change, and then your energy problems with doing like months over years. Just answer the question, what kilocalories, what kilowatt? They will give you all the stuff. You won't need any conversion factors. The only thing that might trip you up is the giga, mega. Okay, but if you remember that chart, remember this thing, that little piece of, I think some of you glued it in your notes back when some of you were taking notes. Let's see, giga, what did I label that as? Giga, I have it on a picture, I know. Let's see if it's just in my APES. I used to just keep it on my desktop to throw it up here. APES JPEG. Oh. Yeah, I'd probably just do a search and find it. I got some things. Hey. We're just talking math. I should send you a quick video that you probably are going to be fine. But like,
yeah, don't even bother. I'm not gonna watch it.
Thank you for your dedication to my class. I'm just kidding. Where's my thing? Well, shoot. Anybody got their notes on them? I don't know why I can't find those papers. Your notes? Let me take a picture of it. Why don't I have all those? I had like a million of them. I probably got cleaning and I recycled it. Hey, Those people, oh yeah, awesome, there it is.
Wait, it's about half-lives?
No, this was about the Giga Mega stuff.
Oh,
Remember that? All right, hey, I know Jeremiah, like if anybody else, did you get these this year or no? Okay, let me explain this real quickly. For those of you who are the first person, okay, I'm not supposed to be showing you this, but this is this year's AP Environmental Science test booklet. Okay, if I tell you the questions, I'm gonna have to kill you. I'm just kidding. This is 2018. They would kill me. Okay, now look at this. Okay, here's the deal. Here's your question. Here's where you answer it. If you're answering this question on thousands of pages, if you're using up the whole space, you're doing it wrong. Okay, answer the question after, here's the question, here's where you write. Notice what this person did wrong on A, B, and C. They didn't leave a space. Okay, please leave a space in between those. Okay, also circle your answers. Okay, see that it's weird. They left a space on some, but not all. Okay. There you go. You're only going to have 3, but you notice what they did do. They labeled each thing A, B, C, D, E. All right. And here's our Giga Mega thing. If you need this, I can print off some more. I got to find my real one. But here we go. 1, 2, 3, 69er, right? Okay. Here's my base. 1, 2, 3, 69. Right? 1, 2, 3, 69. Okay, there you go. So if you got to convert one way or the other, okay, then you know 10 to the whatever scientific notation is. Okay. Yeah, thanks 69er for that. Okay. What questions do you have about the math, about the test, about my tricks and tips tomorrow? What I'm going to do is I'm going to give you one more of those quick little like FRQs. We're going to do an FRQ together. Okay. You're going to write it. And then I'm going to tell you how to take it to that one step. Remember, if it's asking you a question like let's say how is trash ecologically harm a forest? Okay, I graded this one. Okay, and if you say trash could be eaten by an animal, no point. If you put an animal is harmed by the trash, no point. If you put the animal eats the trash, or someone throws the trash on the ground, an animal eats it, and the animal dies, point. Please, please, dear God, say to yourself, have a little jabin on your shoulder that says like, did I go far enough? You want to go, you don't want to go to first base. You want to go all the way, right? All the way home, baby. Okay, right? Make a baby on this exam, kids. I'm just kidding. All right, but seriously, y'all with me on that? Do you see the difference? You've all done this, but like just ask yourself, okay, did I answer the question? How did it ecologically harm? The other quick trick about the APES exam, or that like they'll ask for something like ecologically, and then they'll ask for something like economically, and people answer with ecological stuff. Like how does a dam help the economy? And people put like more fish live there. Okay, that's great, but you got to put more fish live there in the reservoir. People can get on their boat and fish, and that's great tourism, and that helps the community. Y'all with me on that? Read the question, answer the question. Don't ramble.
Probably not.
Okay, that's what we're going to do tomorrow. And once again, I believe in every single one of you in here. Okay,
Do you?
I do.
Probably not either.
You're not even taking it. You should take it though.
Don't even blow me no smoke, David.
So Wednesday afternoon.
Hey, Jabin.
Yeah.
So, did you say we don't have classes in the morning before it?
You have no classes in the morning. You will only be in your SRT from 8:15 until SRT.
Okay. So, do you think I should just come in?
I mean, like, when do you usually come in?
Like 1?
Then I would come in at SRT
Okay.
because I can't. Hold on a quick second. Let me find this John Lippy thing. John Lippy. Let's see. Here's the actual schedule, folks. It looks like this. So 9 through 10, I ready diagnostic tests. 7 through 8, I ready diagnostic tests. 7th, 9th, 10th, and homeroom for those tests. 8th graders will be in the MAO. 11th through 12th is in your homeroom or AP testing. Okay, so period, basically up through lunch. Okay, it's going to be SRTs for all seniors. So if I were you, if you're not coming into 1, I wouldn't come in the morning. Yeah. You're at, you are at, well, that's changed multiple times. So let me see. I think you're upstairs at Phil's room now. Let me ask. Hold on. Metzger 228. 228. Nope, she's not in there. I'll ask tomorrow. Or I'll ask today. But remind me tomorrow. There you go. Any other questions? I can't believe you're having it. That's awesome. That'd be fun. Hey, hey, you guys, I gotta talk to the wife, but that's the 26th field day?
Yeah.
That's you guys want to do the picnic that night at my house?
Wait, the 26th? Hang on, I gotta, let me check the softball schedule. 25th.
That's a Wednesday, right? 26th Wednesday?
I don't know. Yeah, I think it is.
Yeah, it is.
Like 6:30? I think that's when like more people than not. And again, you don't have to come. It's, by the way, it's just for apes. Okay, sorry for other people. Like, keep it on the DL. Don't be like, we're having a senior cookout, right? It's not a. It's apes. It's apes party. No boyfriends or girlfriends. Sorry, unless you're dating someone in this room. Sorry, Avery. What's that?
That's graduation.
What? You can't do the choice?
I don't know, because the games didn't stay on the draw, did it? I mean.
Can we shoot for this and let me know ASAP?
Yeah.
And I'll talk to the wife too. And see what
I probably wouldn't know until like the 24th.
she might have some actually. I think she said I made the concession. If you're an AP art, you also get to come.
Even the filter marker you gave me yesterday, shit.
Did you say the 25th?
How about like, hey, do you have another one? Because this one's just not working very well. Learn some good communication skills if you want a long-lasting relationship with people
I
in
really
life.
don't.
What's that?
You did say the 26th, right?
That's what I want to shoot for. Seems like that works out way better. What about your conference? Will you be done with the conference on the 26th or can you get away?
Yeah, probably. I don't. There's so much going on.
Did you notice what I did?
Yes, I did. I thank you.
Bye, Allie.